You know that glowing rectangle in your pocket? It's probably one of the most brilliant pieces of engineering we touch every single day. But have you ever stopped to think about how it actually works? Most of us haven't. So today, let's pull back the curtain and really get into the magic behind your phone's multi-touch screen.
That's a pretty wild thought, isn't it? I mean, really think about it. Your skin and your screen, they can both feel multiple points of contact. And what's even crazier is they can make decisions based on what they're feeling. This whole idea is the perfect way to start wrapping our heads around the incredibly complex puzzle that engineers had to crack.
Okay, so how do you even begin to build an electronic second skin? Well, it all boils down to one single core piece of technology.
All right, the key word you got to hang on to here is projected. What does that mean? It means the electric field isn't sitting right on the surface. Nope, it's literally being projected through the glass. And that, right there, is the secret sauce. It's why your screen protector, or even thin gloves, don't mess it up. Your phone isn't feeling pressure, not at all. It's sensing a tiny disturbance in this invisible field.
But just sensing a disturbance somewhere, that's not enough. You have to know exactly where it happened. And for that, the screen needs a kind of nervous system. And that nervous system is built on this incredibly fine, totally invisible grid. So right under the glass, there's this invisible grid made of conductive material. Just picture a superfine net. It's made of 40 horizontal rows, you can see them here in blue, and 80 vertical columns, the yellow ones. This grid, this is the nervous system we're talking about.
And when you do the math, 40 rows times 80 columns, you get this number, 3,200. That's 3,200 individual intersections. It's mind-boggling. That's how many different points your phone can sense a touch. Every single tap, every swipe, every pinch to zoom you do is detected at one or usually many of these tiny points.
Okay, I get it. 3,200 points is a lot to try and picture in your head. So to really get a handle on the physics here, we're going to simplify things a bit. Don't worry, the concept is exactly the same. It's just going to be way easier to see what's actually going on.
So here's the basic idea, right? The phone creates an electric field between a row and a column. Now your finger, which is naturally conductive by the way, gets close and poof, it interrupts that field. The phone's brain measures that little disruption as a change in charge on the column, and bam, it registers a touch. Pretty simple for one finger, right? But what happens when you add a second one?
And this is where things get really clever. Because if you just try to use that simple system for more than one touch at a time, you slam right into a massive problem. A problem so big it almost made multi-touch totally impossible.
I mean, just think about it for a second. If all those electric fields are turned on at the exact same time and you touch the screen in two spots, what does the phone's brain actually see? All it gets is a big old jumble of signals. It knows something happened, sure, but it has no clue where.
Okay, let's look at this problem in action. Say you touch these two spots. The phone detects activity on row 1 and row 3. Cool. And it also sees a change on column 2 and column 5. The problem? It has no way to connect the dots. It can't tell if you touched here and here, or maybe here and here instead. It sees your two real touches plus two ghost touches that aren't even there. And obviously, a screen that's just guessing is completely useless.
So this was the puzzle for the engineers. How in the world do you solve this? They had to find a way to get rid of that ambiguity, to get a crystal clear picture of exactly what your fingers are doing. And the solution they came up with? Oh, it's just brilliant. It's incredibly simple as an idea, but just breathtakingly fast when you see it in action.
So here's the genius move. Instead of turning on all the electric fields at once and getting that jumbled mess, the phone does something different. It activates just one row at a time, then the next, in this super rapid-fire sequence. It's basically like a high-speed scanner for your fingertips.
Let me walk you through how this scanning creates that perfect picture. The phone fires up just row 1 and checks every single column for a touch. If it finds one, bingo, it knows the exact coordinate, row 1, column X. Then it instantly shuts off row 1, turns on row 2, and does the whole scan again. By matching which row is on with which column has a signal at that exact millisecond, those ghosts, they just completely disappear. Problem solved.
And when I say this is fast, I mean it is unbelievably fast. Scanning a single row takes about 10 microseconds. To put that in perspective, the entire grid of 40 rows gets scanned in just a couple of milliseconds. It is so ridiculously fast that for us, as humans, it feels completely instantaneous.
All right, so let's put all the pieces together now and see how this insane high-speed scanning translates into that smooth, seamless experience we all know.
So here's the whole process in a nutshell. You start with the physical grid. That creates the ghosting problem that needs a solution. And the solution is that brilliant high-speed scan. The phone's processor then takes all this time-sensitive data and pieces it together moment by moment to build a perfect map of where your fingers are and even where they're going.
Now, this high-speed scanning method is absolutely perfect for the small screen in your pocket. But it does have its limits. Just imagine a giant, table-sized screen. If it had to scan hundreds or maybe even thousands of rows one by one, well, even at those microsecond speeds, it would just take too long. You'd actually start to feel a noticeable delay, a lag, between when you touch the screen and when it finally reacts. So, at the end of the day, this incredible system isn't just seeing a single point, no way. It's mapping the entire shape, the size of your touch. And that's how it knows the difference between a quick tap, a long press, or that two-fingered pinch and zoom that we all do 100 times a day without even thinking about it.
So the next time you're just casually swiping through photos, take a second and remember that lightning-fast scan that's happening just beneath your fingertips. It's pretty amazing, right? And it really makes you wonder, if our screens can already feel our touch with this much precision today, what will they be able to feel tomorrow?